China's first foray into Awacs development began in 1969 with the Kongjin-1, KJ-1, and basically that is where KJ comes from. Codenamed Project 926, this experimental airborne early warning aircraft was based on the Soviet Tupolev-4 Bull, a reverse-engineered version of the Boeing B-29 Super Fortress. The KJ-1 was equipped with a conventional rotodome housing back-to-back radar and identification friend or foe antennas. However, the project faced significant technological hurdles. The interaction between the rotodome and the airframe caused damaging vibrations, but the worst problem was overcoming ground clutter, a fundamental challenge for airborne radar systems. In fact, if the radar beam is pointed toward the ground or the antenna side lobes do point downwards, the Earth's surface reflects back a blanket echo that heavily clutters the radar picture, hence the name. It is not a problem for modern radars, but at the time it was a serious issue. The look-down capability for an airborne radar was not to be given for granted. Due to these difficulties, the KJ-1 project was put on hold indefinitely in 1979 and eventually cancelled. Just one prototype was built and it was later disassembled, and the one that is currently on display at the China Aviation Museum in Beijing is a replica. In the 1960s, China also attempted to develop an airborne early warning version of the Y-10, but this project also failed. Very little is known about this attempt, but these early unsuccessful iterations highlighted the maturity of China's aviation and radar industries at the time. Recognizing the critical importance of Awacs after observing their impact in conflicts like Desert Storm and Light Force, China actively sought to acquire or jointly develop these systems. This is when negotiation with the Western countries began. China explored purchasing the E-3A Sentry from the United States during President Reagan's visit in 1984. Today it may seem very strange, but at the time the Soviet Union was still in existence and both the United States and China had an adversarial stance against it. These efforts, though, as you can imagine, were unsuccessful. Negotiations also took place with several Western firms, Westinghouse, Marconi, Thorn-Hemi, Dornier, and so on, to explore the possibility of a joint indigenous development. But these did not yield fruitful outcome, except one. Harbin developed an airborne early warning prototype by installing the Thorn-Hemi Skymaster radar on the Y-12 Turbo Panda. This was a simplified variant of the radar being developed for the Nimrod Airborne Early Warning 3. It was a derivation of the British search water system in use on the Royal Navy Sea King helicopters from 1978 to 2018. Two of these aircraft were built and used for maritime surveillance, but they were not real Awacs, and the platform did not have the internal room, the range, the electrical power, or the endurance to be really effective. However, these radars must have been really liked by China, because they also expressed interest in purchasing directly the British Nimrod Airborne Early Warning 3. But this project was cancelled by the UK in a very British fashion. Faced with limited options, China decided to collaborate with Israel in 1992 for the joint development of an Awacs based on the Russian Ilyushin 76 platform. The system chosen was the ELTA EL-M 2075 Falcon or Falcon, and it was a good choice. It was, and still is, a very advanced system, very effective. Rather than the rotodome, it uses 4 radomes that can be installed on an airliner or a transport aircraft. 2 along the sides, 1 under the tail, and the characteristic big nose that makes the system instantly recognizable. It seems that it can drive up to 6 arrays, but I couldn't find a specific confirmation. The system in itself is quite bulky, albeit it is based on AISA arrays that give a series of important advantages. Without going too much into the details, we will do another time, AISA arrays give the possibility of updating the tactical situation potentially many times per second, as opposed every few seconds, like it happens with mechanically rotating systems. Moreover, the system came with sophisticated IFF and ESM that were quite important for China in terms of technology acquisition. An official contract was signed in 1996 for one system, and works started on an Ilyushin 76 airframe built in Russia on the same assembly line of the A-50, but delivered with no electronic systems. Once transferred to China, it was made available to the project. Initially, Israel provided a modified Falcon radar with antennas mounted on the aircraft fuselage and nose dome. This configuration, though, could provide only 260 degrees coverage, which was not acceptable for the Chinese. They wanted full 360 coverage, and they suggested a stationary radome on top of the fuselage with phased array planar antenna technology. At some point, though, the United States exerted a very strong pressure on Israel, leading to the cancellation of the deal in 2000. A significant setback for the Chinese ambitions. The work done to integrate the system on the Ilyushin 76 will be later used by India, which currently has 3 of these systems in service, and this is quite an ironic outcome in the light of the recent Sino-Indian frictions. The cancellation of the Israeli deal spurred China to accelerate its indigenous AWACS development efforts.